So as always, we are joined today by Tad, the planetarium educator. We are very fortunate in that today he's at the museum inside the dome. I'm going to turn things over to him to talk about stargazing in the month of September.
All right, thank you, Amber. Yes, hi everyone. My name is Tad. I am right here in the Bell Museum in the Whitney and Elizabeth Macmillan Planetarium. I am using the dome as my real background today, so you might catch a glimpse of some astronomical images swirling behind me. Right now, we're looking at I don't remember this one. I've got a set of them that I'm cycling through, and can't remember which one this one is. But today we're also going to be looking at our sky, and to be doing that, Amber's going to have to let me screen share. To do that, we forgot to test that. I'm going to be using the program Stellarium. If you've tuned in before, you've heard me talk about Stellarium. It is an amazing piece of software. It is possibly just my absolute favorite way to stargaze inside, when it's raining out, when it's cloudy out. I just turn on Stellarium and I take a look at things. If I'm at home, of course, if I'm at the dome, well, I just use the planetarium. But Stellarium is really great because it gives us a view of the sky from whenever and wherever we want to be. So for example, today I am starting off here in Minneapolis in the Twin Cities, and I'm starting actually tomorrow morning, so a few hours from now. Now, I know today we will be talking about the sky in September, but I want to start off with what you can see tomorrow morning. It looks like it might be clear enough that if you're looking to the south-southwest, and you can see the cardinal directions are at the bottom of the screen. If you're looking to the south-southwest, you won't see those lines there. Those are constellations. But looking up there in the sky around 5:10 a.m., you might catch a glimpse of a little point of light moving across the sky. May not appear as bright as the point of light you're seeing on the screen here, but it is still visible. And it'll be visible in the sky for 5 minutes. It'll move from the south-southwest upwards at an angle in the sky over to the east, east-northeast. So very bright, very easy to see. All right, that's cool. What are we looking at though? Well, another great thing about Stellarium, it tells us. Tomorrow morning, we get a chance to see the International Space Station, marked out here, though, in Stellarium as the Crew Dragon 2, which is currently the spacecraft attached to the ISS, which helped ferry a handful of astronauts up a few months ago. So we have a pass of the ISS tomorrow morning. There are people out there with really great telescopes and cameras that are even able to get pictures of the ISS when it flies above our heads. I've never done that personally. I just love going out and looking for it, looking up there, realizing the fact that there is a football-sized field piece of engineering orbiting around the Earth at 17,000 miles per hour once every 90 minutes. And it astonishes me every time I get to see it. Right now, there are 7 astronauts on board it looking down at me. I'm sure they're looking right at me, of course. And there are also 3 other astronauts up in space as well, or rather, these are taikionauts, astronauts from the Chinese Space Agency, and they're on board their own space station, the Tiangong, which I apologize, I probably mispronounced, translates roughly to Heavenly Palace. So we have 10 people all together in space right now, ramping up for hopefully dozens, even hundreds, thousands more in the next few decades. Now, if you want to relive this past the ISS, you can head out tomorrow morning. If you're not able to get out tomorrow morning, or if it's cloudy, there are places you can go to find out where to find the ISS. And the first best one is spotthestation.nasa.gov. And Amber's helping me out, I think, by putting that in the Facebook chat there. There are links on Spot the Station. You can put in your location on Earth or whatever location you want, and you can find out when the ISS is supposed to go above your head over the next week or two. Now, when I checked the passes for the next week or so are all in the morning. So apologies to that. NASA unfortunately did not ask me, but it does change, especially if the space station has to move at all. They do change its orbit occasionally, just a few miles here and there, to help avoid space junk or other stuff. And so if you aren't a morning person, just keep your eye on the website, and I'm sure it will come back around again in the evening. Speaking of coming back around, we're going to head to September. So looking at our sky here in September, there's so much to see. And, as I go along, two things I want to mention here. The first is that I'm talking, a bunch of different things. Feel free to ask questions as well. Put those questions in the chat. Amber will get them to me and I'll answer them as quickly as I can. But I love questions. I love answering questions. So please take all the questions you have and throw them in the chat and let's see how many I can answer. We are looking at our sky here. And one other thing I want to mention right now too is that, I am looking at the sky and I'm talking about constellations and deep sky objects that are notable within Western astronomy. In particular, the constellations that were defined by the International Astronomical Union about 110 years ago. Now, these are the constellations I'll talk about, but there are many more up in the sky. In particular, right here in Minnesota, there are cultures like the Ojibwe and Dakota and Lakota that have their own astronomical knowledge. And so I encourage you to seek out resources to learn more about that indigenous sky knowledge. One site in particular, my favorite, is nativeskywatchers.org, run by Dr. Annette Lee. Native Skywatchers is a fantastic site to learn more about the night sky. And this is something that's important because, we are sitting right here, or at least where I'm at the Bell Museum. If you're on the Twin Cities campus, you are sitting on Dakota land. It is really important to remember the heritage of people who are here before and still here right now. Important to remember that they're here and to remember that they have their own ways of knowing the sky, the earth, and the universe. From that, let's take a look at some of the brightest things that have surely been seen over tens of thousands of years of human history. In particular, going backwards just a little bit, starting here in September, we have our bright planet Venus near the constellation of Virgo, the Maiden. Now, Venus is kind of hard to see because of how close it is to the horizon. Besides that, it's very easy to see. Venus is the brightest planet in our night sky, so you really can't miss it if you have a good, clear view of the horizon. Now in Stellarium, I set up a landscape here that doesn't have a lot going on, but if you're right inside the city, you're probably going to see trees or buildings maybe in the way instead. But if you try to get up to the top of a building or find a gap in the trees, you could look for Venus, one of the closest planets to the Earth, just one planet inwards from the Earth towards the sun. And our sister world, Venus is long been considered a sister planet to the Earth. It's about the same size. It's another rocky planet. It even has a very thick atmosphere. And that's why we can see it so well. This thick atmosphere covered in clouds of sulfuric acid reflects an immense amount of light back to our eyes. But if you know anything about Venus, or you're really listening there, it's not a very pleasant place besides that. I just said clouds of sulfuric acid, and it does, those upper cloud tops, very bright. You don't want to fall into those. And even that sulfuric acid doesn't last forever either. As that sulfuric acid falls down, as it rains down on the surface, it evaporates long before it ever reaches the ground, because the surface temperature on Venus is about 900 degrees Fahrenheit, wherever you are. So an atmosphere that could burn you alive, a surface that could boil you alive. Oh, and also it could crush you like a soda can, because the atmospheric pressure is about 100 times that of Earth. Magnificent place. I mean, it may not sound like it from what I just said, but it is really important. It's a planet that is still like the Earth in mass, in somewhat in composition, roughly in distance from the sun, and even the atmospheric conditions, this extreme heat caused by a runaway greenhouse effect. Studying these conditions are important for understanding weather and weather models and systems here on Earth, especially as we track the long-term changes in our climate. So not the day-to-day thing, but the long-term changes over decades and centuries. Understanding Venus gives us a way to test our models, as well as a way to understand how the Earth got to be the way it is right now. NASA has 2 missions headed to Venus within the next decade, Veritas and Da Vinci. And those 2 missions are a lander and also an orbiter, and they will show us some incredible things about our sister planet. Now, Venus, so if you want to look at it, it's hidden a little bit behind the horizon or behind the landscape if you're here inside the city. It's also sinking closer and closer to the horizon as the month goes on. So if you want to see it, you've got a few weeks here in September really to pick it out before, at least in the very early evening, before it really gets just too hard to see. But going forward to about mid-month and a little bit later in the night, maybe about think 9:30 would probably be pretty good here. There is a lot more to see. For example, there are 2 planets there, but there are also, or there's 1 planet over there, but there's also 2 others right over here. Looking over to the southeast at September 15th, right around mid-month, or throughout September, but especially around mid-month, we have both Saturn and Jupiter near the constellation of Capricornus, the goat. And it looks like the artwork for Capricornus isn't coming up. Capricornus is kind of a bizarre constellation. It's a sea goat or a mere goat, so a goat top and then the bottom of a fish. It's a bizarre constellation, very old though, coming to us from the Babylonians, but it looks like it's not popping up today. That's okay, because we've got Jupiter and Saturn. They're both amazing. I'm gonna give myself only a minute to talk about maybe both of them, because otherwise I'll just talk forever about Saturn. And I love Saturn. It is the best planet in the solar system. You should basically just spend all of your time looking at Saturn. That's really, really my advice for it. It is incredibly beautiful to look at. That beautiful ring system going around it comes into view. If you have binoculars, it'll be a bright oval. Smallish telescope, 4 inches up to, starting at maybe 4 or 6 inches. That'll bring out a distinct ring system, that actual ring around it. Getting up to an 8-inch telescope, going larger, you can start to pick out the gap inside the rings. The main gap here, at least the Cassini division, caused by one of Saturn's moons, in particular the moon Mimas. See if Mimas is popping up here. There's Tethys. Turn the labels on. Oh, there is Mimas over here. Mimas, as it orbits around Saturn, this moon and its gravitational pull pulls on the particles in the ring, the bits of ice in the rings. And Saturn's also pulling on them. So we end up with this area in the Cassini division where there's an instability, a gravitational instability. Nothing can stay there. It's kind of like standing right trying to balance on the very tip of a pin. Either go one way or the other. And that's what's happened to the ring particles as well. Other gaps in the rings are formed by other moons like Pan. There's a very small moon over here that we can see now on the far side. And in fact, all of the bright moons that we see here all have their own effect on the rings. And so we see incredible detail and structure within the rings of Saturn. It's so beautiful to look at. If you don't get a chance to see it like this, look up images from the Cassini spacecraft. Cassini was a joint NASA and European Space Agency ESA mission. It was around Saturn for 13 years. Opened up our eyes to this world. If you're also if you're looking for a moon, if you're getting a chance to look at Saturn, probably the easiest moon to look for, the first one you'll see is way over here, the moon Titan, which is a bizarre moon. One of the only, in fact, the only major moon with a really thick, substantial atmosphere. And it does in fact look yellow. The moon Titan is covered in this methane, nitrogen-rich atmosphere, and red-orange light is scattered there because of the nitrogen. And so we get this orange haze, this red-orange haze covering it. It's a crazy world, freezing cold, but covered still in liquid oceans of methane and ethane cover Titan. It is a place as well that NASA is hoping to go back to with the Dragonfly mission, which is still in development right now, but I believe being worked on. And last time I checked, it was going to head to Saturn within the next decade and to land on Titan. And fingers crossed that happens. All right, heading over to Jupiter, though. Jupiter is over to the east of Saturn in the sky, but much closer to us, only 500 million miles away instead of Saturn's billion. And another magnificent world, not as great as Saturn, but still really great. Looking at it, in fact, if you grab a pair of binoculars, the first thing you might look for are these little dots around Saturn. You can see them very clearly right here, lined up on either side, 2 on either side. We have the 4 Galilean moons, Ganymede, Io, Europa, and Callisto. Although actually in order out from Jupiter, it's Io, Europa, Ganymede, and then Callisto. But, they aren't always in the same spot. These moons are orbiting around Jupiter. And in fact, if you get a chance to watch Jupiter over the course of a couple hours, not even like sustained look, just go out, look for it for 5 minutes, find out where the moons are, draw a quick little sketch, nothing fancy, just 5 circles, Jupiter, 4 moons, or maybe only 3, or maybe even only 1 if you can't see all of them. and then head out later, head out maybe half an hour later. And when you do that, you'll see, just like we're starting to see here, the moons will be in different positions. They'll be tilted as well as Jupiter rises higher in the sky, but especially moons like Io, and we can see here Ganymede as well, for the morning of the 15th, they'll be drawing closer and closer together, just bit by bit. And if you go out over the course of a night, every half hour, every hour, you can see this change for yourself. If you go out over days and weeks and months and years, you can definitely see it. Oh, and Jupiter might also go right below the horizon if you're watching it too long and too closely. So probably don't do that. And if you do this, though, you'll be following in the same footsteps of Galileo, the first person to look at Jupiter with an instrument, a very small telescope 400 years ago, and who was able to determine that what he was seeing at Jupiter was a planet, and a planet with something going around it. Sounds simple. Big news 400 years ago, though. Put a good pin in the, or gave some really great evidence for the heliocentric model of the solar system, or at the very least against the geocentric model, the idea that we were the center of everything, the Earth. Turns out not to be the case. Now, Jupiter and Saturn here are very bright. They're very easy to see on their own. The moon, though, is another great guide to finding them over the middle of the month. In fact, looking here at the middle of the month on the 15th, we've got almost a straight line with Jupiter, Saturn, and the moon there. If we go forward to the night of the 16th, it's still at 9:30. We've got a nice sort of sideways L here, Jupiter, Saturn, and then down to the moon. Going forward to the 17th, it almost switches positions here. We have a bit of a diagonal, sort of a very lopsided triangle there. And then going forward to the 18th and the 19th, we bring back this long line in the sky here. And then if we go forward all the way to the 20th, we end up with our full moon, very, very bright, making it kind of hard to see other things in the sky, especially the stars, but still a beautiful sight to look at. The full moon on the 20th is also the closest moon to the autumn equinox. The autumn equinox happening on September 22nd. And because of this, the September full moon will be known as the harvest moon, the closest full moon to the autumn equinox. The idea coming from the fact that we had the full moon here, it's visible throughout the entire night, and it gave farmers extra time to bring in their crops because, well, that's where we are by the end of September. Bringing in the crops, waiting for those very cold months and that stuff that falls from the sky that I won't mention more of. The full moon as well in September is also another special sight because it is going to be a blue moon. It is the third full moon out of 4 full moons in our season, in the fall season. So the moon the September moon will be the blue moon. That being said, it will not look blue. It will not change color, look really different in appearance. It will not be any bigger or any brighter. It will just be the third out of 4 full moons in a season when we usually just have 3 full moons. But people tend to get very excited about that. So I thought I should mention it. All right, taking a look back at our sky, we have our moon, and taking a look through my notes, so I make sure we get to some of these things here. There are a lot more constellations up here. I mentioned Capricornus. If you saw the moon as it was going along, it was in Pisces, the fishes, and I actually want to come back to that one a little later. But oh yeah, and Jupiter here as well is right nearby the star Deneb al-Jedi, which as I was looking up, as I was familiarizing myself again, refamiliarizing myself with the September sky, I realized, oh, Deneb al-Jedi, I know that name. But I was thinking of another star. If you've ever heard the star Deneb mentioned in astronomy, it probably wasn't this star here. It was probably the star Deneb that's part of the summer triangle. And Deneb is still visible in our sky. It's visible right up near the top of the sky, what we call the zenith. You can see it and the summer triangle really throughout the month of September. Just go outside, look roughly to the south. So that's going to be the sun is going to be on your right, where the sun set rather is going to be on your right, and that way you're facing south here in the northern hemisphere. And looking up near the top of the sky, you'll see 3 very bright stars: Deneb in the constellation of Cygnus, the swan; Vega over here in the constellation of Lyra, the harp; and then finally Altair in the constellation of Aquila, the eagle. And looks looks like none of the images are working today in Stellarium. So I hope you have better luck when you download Stellarium. You should see images popping up for these. They're fantastic drawings of the constellations. But Deneb is the star up here that you might be more familiar with if you've heard the word Deneb. It's a common star name, though. It turns Deneb, it comes from Arabic, means the tail. So we find tails all across the night sky because we find a lot of animals. Cygnus, again, the swan or the goose. And as well here in Aquila, we have, see if I can find the star I'm looking at. We have as well a star that should have Deneb in it as well because it means tail. I'll track that one down later. And that repeats across the rest of the sky. Many of the star names that we see come down from Arabic astronomers. They made incredible maps of the night sky. They charted the stars as they moved. They gave them names so they could remember them. They attached their own stories and important cultural traditions to them, as we do right now today. Now, if you're looking for the summer triangle, there's also a few more constellations you can find in this region of the sky as well. In fact, at the end of Cygnus, rather coming up from the tail of Cygnus out through the end to the head, we find the star Alberio, which is an amazing double red-blue double star. But in between the star Alberio and the star down here, Altair in Aquila, there's a couple more constellations. In fact, you can start to see one right in between, almost equal in between either of these two stars. Just a handful of stars here that make up Sagitta, the arrow. A very simple constellation, just 4 stars here as we draw it, really only 4 stars that we can pick out there, but still decently bright enough that we can see from within inside the city. As well, if we look a little bit above it, we also see a couple bright stars rather, that make up the constellation of Vulpecula, the foxes. See if I get the name up for that one. Sometimes my Latin isn't so great. Vulpecula, the foxes. These are 2 fainter constellations. By that I mean the stars are a little bit harder to see, mainly because they're sort of by their lonesome there in the sky. But you should still be able to see them from within inside the city. And by that, I mean when you have all this light pollution around you. Now, if you get outside the city and you get away from city lights and away from this light pollution, you can start to see a lot more stars. In fact, the night sky would start to look a little bit more like this. Dozens, thousands of stars come into view where before there was nothing. As well, when you're getting out into the dark skies, you can also start to look for some other objects there too, deep sky objects. Groups of stars or nebulas or galaxies that you can see with the aid of binoculars or a telescope. Some great ones are actually right around these 2 constellations. I'll bring up a bunch though, as Stellarium does. The first one actually that I want to point out is over to the right of Vulpecula and Sagitta. This is a group of stars we call an asterism, and it's known as the coat hanger. And you can see it right over here with the stars here in a line, and then the stars that come up this way in sort of a curve, and you get a coat hanger upside down though in the sky. So stand on your head if you really want to see it right ways up. Okay, that may not sound like much, but simple asterisms like that are a great way to get acquainted with finding fainter objects in the sky, more complex shapes, especially if you start to come over to some of the things mentioned or marked out here. In particular, if you're looking for something like a faint group of stars, you could look for what's known as the Poodle Cluster. Now, I laughed a bit when I first saw this one, and I really had to think, why, how, what is the Poodle Cluster? And so I decided to look up. Stellarium didn't give me a quick image of it here, but I decided to look it up, and I found it actually, this is a pretty well-named deep sky object, also known as NGC 6830. The Poodle Cluster, which is now visible here, is marked out by these stars right here. And if you really look, you kind of get a poodle. And I'll actually zoom in a little bit on that. I'll remove my awesome drawing there, and I'll zoom in a little bit more, and maybe you can see that a little more clearly. The nose up at the top here, the long neck, the body coming back, the little tail sticking out, the legs going down here. Yeah, it's a poodle. And you know, I'd never looked for this one before. This was I'd never seen it before. I never really realized it was there. But this is my new thing to look for now. As when I go out here in September, even right now it's going to be visible. But when I go out, I'm going to look for this one because I think I could actually see that one. Out of all the things that are named like what they're named like, I think I could pick that one out. As well, what I was really looking for as well was over beside it, something known as the Dumbbell Cluster, or the Dumbbell Nebula, excuse me. The Poodle Cluster is a group of stars. The Dumbbell Nebula is the first ever discovered planetary nebula, a dead star. So what we're seeing right here is a star kind of actually similar to our sun, about a mid-sized star. And about 10,000-ish years ago, it reached the end of its life. And as it did that, it expanded outwards. And the outer layers of the star puffed off into space. And that's what we see in this sort of reddish region, this bluish circle here. In fact, these are all the outer atmosphere of the star puffing off into space, dissipating away. The inner core of the star, though, it started to shrink down. It shrank down very, very quickly, and it became a white dwarf star. And the light from that white dwarf star, the energy coming out from it, is causing the outer atmosphere, the remains of the atmosphere, to glow, to emit light. And that's why we get this incredibly complex, beautiful shape here. The core of a dead star powering the remains of the rest of the dead star. This is a beautiful nebula to look for. It gets its name, the Dumbbell Nebula, because when you look at it through a telescope, and if your eyes aren't going to see all those colors, it's more grayish, and we get two brighter lobes on either side that look like a dumbbell. Now, I know it's been a long year and a half with COVID. So for those of you who've forgotten what a dumbbell is, it's something we used to lift up and down to get in shape. But then the gym's closed and everything just went downhill from there. On that note, the Dumbbell Nebula is just beautiful to look at. And it's a great distraction from the world sometimes. Looking up in the night sky, looking for all these beautiful objects. And there are so many more as we look in the night sky. Stellarium marks out a ton of them, more than we would really expect to see in any given night, but we can always use those constellations to track them down. So, you know, I started here after coming from Venus. I went over to Jupiter and Saturn and Capricornus. I clicked on the moon there, and that showed me that was in Pisces. And really with just a handful of constellations you can find, and then we went up to the Summer Triangle, and as well the fainter Sagitta and Vulpecula. And, you know, with just a handful of constellations, you can find a lot of things. But some of the brighter things are near a few other constellations that I'll point out. In particular, as we head into the fall, we leave the Summer Triangle behind, and we find a new group of stars more appropriate for the fall. And it's called the Fall Square. All right, you're all with me, right? And didn't get too wild there. I mean, we added a whole other line. But the Fall Square is made up of 4 bright stars right over here to the southeast. It looks like a square in the sky. I don't know how to make this one more clever. It's a square. It's 4 bright stars. It's incredibly easy to see. And it's also sometimes known as the Great Square of Pegasus. So Pegasus here has these 4 very bright stars making it up, along with other stars stretching off from the square. So in fact, to me, this constellation looks a lot more like a squid in the sky, or like an octopus, maybe floating through the sky there, or well, swimming through the sky, excuse me. Octopi don't float, they swim. Now, this is a really great constellation to find, because if you come off what is usually the head of Pegasus, these 4 stars over here that form a rather simple sort of almost like just sort of a crooked line there. These 4 stars point to a really beautiful deep sky object, one of my absolute favorites in the sky. It's actually coming right off from the star Enif. Enif is the nose of Pegasus. And coming off from Enif, just a few, like a hand width away, we can come up to the Pegasus Cluster, also known as M15. M15 is a globular cluster, and it is simply stunning. It, like every globular cluster, of course, it is incredibly amazing. M15 has rapidly, over the past few years, become one of my favorite globular clusters to look for. Along, of course, with M13, for those watching, you know, M13 is great. M15 is really just as great, though. It's like other globular clusters going around the Milky Way. It is about 30,000 light years away. It is one of the oldest ones we know of, though. It's about 12 billion years old. So the approximately 100,000 stars we see in it all formed back near the beginning of the universe, which is crazy. Thinking Stellarium M15, I think you just thinking about this, these stars are 12 billion years old. Maybe you can get a taste of how incredibly old the universe is, and how brief a span of time we humans have been around. The first humans, for example, the first human fossils, what we consider sort of modern humans, we found those dating back about 2-ish million years ago. 2 million years, not billion, just 2 million. And these stars have been around for 100 times more than that. It's incredible. They've been around so long that this globular cluster has undergone something known as core collapse. Core collapse is when the inner part of this cluster of these stars, thousands, tens of thousands of stars near the center, when they quite literally collapse down near their core. Gravitational interactions slow them down, and we get this mass migration inwards, leaving us with a very dense center and then more spread out collection of stars around it. Giving it then a very distinctive thing to look for, a bright center and more fainter surroundings. Astronomers who've also spent a lot of time looking at M15 discovered something really amazing a few decades ago. They found the very first planetary nebula in a globular cluster, known as Ps1. This is the first one found in a globular cluster, and there's only been 3 others found since then. So planetary nebulas like Ps1 or the Dumbbell Nebula, they are fairly common. We get them from small, medium mass stars, similar to our sun, but they also don't last that long. The Dumbbell Nebula, for example, that's about 10,000 years old. And I wouldn't expect to see that I would expect to see that dissipate in the next 10,000 years. So lasting just 20-ish thousand years altogether. Eventually that material dissipates out into the interstellar medium. So getting a glimpse of a planetary nebula in M15 was an incredible sight. It gives us a good way as well to understand the age of the globular cluster, because it takes a long time for small stars to die. So being able to see that globular means that we know, well, we get an idea of just how old it is. Again, about 12 billion years. Now, as you might have seen, as I was clicking around, this star here over in the square of Pegasus the Great Square is actually shared with another constellation. It's shared with the constellation of Andromeda. Andromeda, the princess, stretches out here from Pegasus and kind of stretches up in the sky. These are her arms going out above and below her. These are actually, as in the mythology, as she's chained to a rock waiting to be devoured by Cetus, the sea monster, which we don't have right here. I just want to keep Andromeda up there. But as her arms are stretched out, she's waiting to be devoured, but will be soon saved by the great hero Perseus, which we also find right nearby Andromeda. Now, there is a really incredible deep sky object to look for near Andromeda. It was already marked out. In fact, it's conveniently right by near the label Andromeda, and we can see it over here. This is the Andromeda Galaxy. So coming into our skies in the fall is the closest major galaxy to our own, M31, with approximately 200 billion stars. It is a galaxy very similar to the Milky Way. And you can see it if you're under very, very dark skies. You might even be able to see this with your own eyes. No special equipment needed, no binoculars, no telescope, just a little faint smudge up there. Binoculars and telescope do help, though. They do bring into view as more of like a football shaped smudge in the sky has been my recollection and my notes of it. And if that's disappointing, if you want to see it more like this, don't despair. You don't even need the Hubble to do it. You just need to wait around. M31 is on a collision course with the Milky Way galaxy. So the Andromeda Milky Way galaxies, rather, they're on a collision course with each other. They're headed towards each other at about 70 miles a second, or excuse me, 70 miles an hour. They're drawing closer and closer. So soon, Andromeda will actually look just like this on our night sky. Give it just about 3 billion years. It's going to be a beautiful sight. All right, that was a bit of astronomical humor for you all there. Now, looking here as well near Andromeda, we have another nice simple constellation as well. So in fact, I'll bring up as well the square here, which is these 4 stars. Coming over from the square, looking further to the northeast. So if you see the cardinal directions down there at the bottom as well. We have 5 stars that form a simple shape, just a very nice little W here. Or since I am here at working with the University of Minnesota, I guess I tilt my head way to the right. And yep, that's an M, perfect. But this M is the constellation of Cassiopeia, the vain queen in the sky, who is in fact sentenced to live out her remaining years in the sky, perched invisibly on her throne as punishment for her vanity. Cassiopeia is another great way to find the Andromeda Galaxy. You can take the triangle of stars at the one side, form almost a nice equilateral triangle, and you can imagine a line coming straight up from that about a hand width away, and that'll point you right to the Andromeda Galaxy itself. So Cassiopeia is a great way to help find that particular, there it is, that particular deep sky object. Now, because the Cassiopeia, because of where Cassiopeia is in the sky, there's a lot to see around it. Where it is in the sky is right within the path of our Milky Way galaxy. I'll make the Milky Way a little bit brighter here. It's get a lot brighter actually. The Milky Way galaxy is an incredible sight. I hope really that you all get a chance to see it. If you go outside at night, you do need darker skies, and you can see it as this band across the sky, this very faint glowing band there, quite a bit like someone spilled milk across the sky, which is where its name comes from Latin, Via Lactea, the Milky Road. This is our home galaxy, the thing that's going to let us go on the collision course with the Andromeda Galaxy. And it's amazing. And this is truly home. All the stars we see, everything except for the Andromeda Galaxy, everything we see in the night sky, all part of the Milky Way galaxy. All these stars, including our star and all of our planets. So you get a chance to look at home there, arching above your heads in the sky. But because what we see when we look at the Milky Way is more than just stars, it's also a lot of gas, it's a lot of dust, it's a lot of dead stars like the Dumbbell Nebula, it's new stars forming. And because this is the densest part of the Milky Way, we're looking right inside the right along it, the spiral arms here. This is also where we find a lot of very bright and easy things to see. Cassiopeia, the constellation we're looking at, is I think is a really, really great one to start with if you're really trying to track down deep sky objects and you're not picky about what you're looking for. You just want to see some different things. The constellation itself, very easy to find, those 5 bright stars in a simple W or an M. And then all nearby it, we have different clusters of stars. One of my favorites, for example, Caroline's Rose Cluster up over here, an open cluster of stars that actually does look quite a bit like it has rose petals when you look at it in the night sky. A fairly young cluster of stars. In fact, many young clusters fall all along the Milky Way galaxy. We also have, though, these star-forming regions. We have areas where new stars are forming right now. For example, this is 7822 over in the constellation of Cepheus. Now, I wouldn't expect to see it like this when I look in the night sky, but I might be able to, especially with a telescope and a hydrogen filter, I might be able to see wispy clouds of gray there, showing clouds of hydrogen gas that are collapsing downwards and forming into new stars. But again, all very easy to track down just because you're right around a bright constellation, the bright constellation Cassiopeia. And nearby, I mentioned, is the constellation of Cepheus. This is the King Cepheus, along with married to Queen Cassiopeia. He, though, as someone pointed out, and now I can't not see it, these lines as we draw them here look a lot more like a dog's face, with the nose coming down at the bottom in that triangle, and then the floppy ear coming out from one side, and then the other ear over here on the other side is kind of bent over. And it's an adorable, and the 2 eyes over here and here. I just can't not see that. Someone pointed that out to me, and now I think hopefully you all see that as well as you look at the sky. All right. I've been talking on and on and on here, and I've just gotten a chance to look at the time, and I realized, wow, I just breezed right through and past my time there. And so I want to check and see, Amber, has anyone had any questions along the way? Have you just been letting me ramble?
No, we have some friends that have just been sharing with us their locations throughout Minnesota and Wisconsin. A couple of people mentioning that they're really excited for fall stargazing. Obviously,
Yes.
what we see in the summer, and looking forward to all the things they can see around the fall square. We did have one question from Jennifer about Stellarium. She's saying that her interface looks a lot different than yours, and she's just wondering if you can talk more about the version you're using. Are you using the web or the app? I think she's wondering how she can get your version of Stellarium.
Yes, great question. So I am using the computer, laptop, desktop based version of Stellarium. There is, as you're saying, there is a mobile version, and there is also a simpler web version. The web version is simpler. It's more, there's less available there, but it's really great for like quickly finding out what's in the sky. It's also one of my favorite things to use. And I might try to bring that up here just as I talk along. To get the version I am using, if you head to stellarium.org, and Amber, if you don't have that, I'll put that in our chat here, the Zoom chat, and you hopefully get that and copy and paste it along. But stellarium.org will give you an option to download the versions for desktop. And the versions for desktop, quite naturally, there's a lot more available. There's a dozen different hotkeys. There's options to add different grids across the sky if you're really tracking down deep sky objects and you want your different grids to learn where different things are. There's options to bring up meteor showers, which I was going to talk about in just a minute, but then I looked at the time. Long story short, there's not a bunch of meteor showers in September, so don't despair. That actually really was the long story short. There aren't a lot of meteor showers. You can also do things like if you're connected to a telescope, you can control a telescope with Stellarium. You can also do things like, we really zoomed along there. You can get a just idea of what something might look like when you're looking at it through a camera or a telescope. So for example, this is a view, this is what I do actually quite frequently when we're setting up for our star parties. We have a Canon T6. We actually have a C925. Well, you know what? I own a Celestron 8-inch, so maybe we'll just try to get that back. Oh, there's our 95. So this is a view of what our camera sensor sees. So when I'm setting up and trying to decide, you know, what are we going to look at for our star parties, I'm going to use that little sensor box, and we can see some things. We can see part of the Andromeda Galaxy. It's a very big object. If we're looking for something like the Dumbbell Nebula, oh, there we are. You know, that's something we can capture in a single sensor frame here. It does take a bit of work though with the full version to figure out where all the settings are. And there are a lot more settings, things you can change from everything from how many stars you see to how bright the Milky Way is. You might have seen me doing that really quickly, as well as what type of deep sky objects. So it takes more time, but I think it is well worth it. And again, that's stellarium.org. All right, I think I'm done with that question, Amber.
No, thank you. I haven't seen any additional questions. People are just really excited to take this information and do some stargazing, and a couple of thank yous to you.
You're welcome.